All right, so today we're going to do a lesson on special segments, and really I would call this more chord theorems and secant theorems, yeah? We've already talked about, in the previous two or three lessons, the relationship with the angles and the arc, right? We know that, right? What did we discover about that angle and these arcs? Angle x is the average of those arcs, right? Right? So today we're not going to be dealing with the arcs. What we're going to be dealing with is the parts of the chord. So if you look at this, like A, B, C, and D. How long are the chords? I've seen this proved before, and you're dealing with, I think you're dealing with similar triangles, if I'm not mistaken, when you start doing these. We're not going to go into the proof behind it. The proof, I've done it before, and it's not that complicated. They're pretty easy to do. I think you have to draw an auxiliary line somewhere, and you start seeing it pretty quickly, all right? But on these problems, what you're going to discover, and it's real simple, is if you have two chords intersecting, A times B is going to be equal to C times D. And what am I saying? I'm just basically saying this part of the chord times this part is equal to this part times that part. That's it. Is that hard? All right. So that's one chord theorem. You might also have one like this, where you have two secants, yeah? Right? So you have part A, B, C, and D. Let's get this out of the way really quick. It is not A times B equals C times D. I'm going to teach you how to memorize this. That is not true. All right? What it is, memorize it this way. It's the outside times the whole thing is equal to the outside times the whole thing. So the outside would be what? So A times the whole thing, A plus B, is equal to C times C plus D. Pretty simple. They can give you, once you get those two down, all the rest of the ones that I would show you are just some variation of that, yeah? If I had a tangent with a secant, then I'd have A, B, and C, right? What did I say the formula was? The outside times? So the outside, A, times the whole thing, A, is equal to the outside times the whole thing, B plus C. It's not a new formula. It's just that one. You could actually do it with tangents if you wanted to. If you had two tangents, there's no reason to do this. But if I had two tangents, A and B, A times the whole thing, A, is equal to B times the whole thing is B. Oh, wait. So that's A squared equals B squared, or A equals B. Well, we already knew that. These were equal, right? So you could still use it to generate it. Okay? And so you could do any one of those. I think you can also do, no, I think that's it actually. I think that's all four of them. If there's another one, I'll pop it up in a minute. But those are easy. Once you get them down. These sometimes, I will tell you, these right here tend to go quadratic on you at some point. So just be aware of that. Those will go quadratic on you when you start doing the math for them, all right? Yeah, usually when the outside is x. All right, so let's do a few of these. So that's all we're saying in example one, right? We're saying that if you have a chord, A times B is equal to C times D, right? So we know that A, given that picture there, right? What do we know? 6 times x is going to be equal to what? 3 times 8, right? It's easy. So divide by 6, we get x equals, what is that? 4. Easy? All right. Next problem, example 1. What do we know? Two chords intersecting. So 2 times is going to be equal to 3 times 6. Divide by 2, we get x equals 9, right? Easy. What they'll like doing sometimes is they're like hiding this. Maybe they'll do it in a minute. Let's see if they did one. Oh yeah, cool. They do it. Well, yeah, no, yeah, they're hiding it here. That's good. All right, let's look at 2. Okay, so be careful. What is 10 there? This distance is 10, not the whole line. Yeah. Okay. So remember, it's this piece times this piece, right? All right. Well, how long is that piece then? So I'm asking you, how long is this from here to here? Okay, explain 18. It is 18.
Because the bottom 10 is the radius.
So that's 10, good, and that's 10. So the diameter is 20, and if that piece up there is 2, then 20 minus 2 is 18. So this piece has to be 18, yeah? Okay, so what do we have? We have 2 times 18 is proportional to x times x, yeah? Or x squared, yeah? That's actually x squared. Square root. What's the square root of 2 times 18? That's going to be what? 2, 2, 3, 3. So what's that? 6? X is 6. Is that the question? Yeah. All right. Example 3. Well, this is easy again, right? 6 times x is equal to 8 times 8. Divide by 6. We get x equals, we're going to cancel a 2. Yeah, I'm going to leave it as a, I know they say round the nearest tenth, but I'm not going to do that right now, right? I'm going to leave it. So what is this? 32 thirds. I'm totally happy with that. They say round to the nearest tenth if necessary, but on your homework, if they say that, then round it. Yeah, I'm not going to round it here. It's better that way. All right, so this one will go quadratic on you. Example 4 will go quadratic on you. All right, so what do we get? We get x times what? X plus 7 is equal to 3 times 6, right? Or 18. So we get 18 equals x squared plus 7x, yeah? Minus 18, you get x squared plus 7x minus 18 equals 0. You get a quadratic, yeah? All right. So you're going to have to turn it into 2 things being multiplied, right? Remember this? All right, it's been a while. If you're in geometry at this point of the year and you haven't done quadratics the whole time, the last time you did them was February of last year. Okay, it's been a while. So remember the process. If you want to go back to the videos and watch this, right? It's the table, right? 1x squared. Remember this? A product of negative 18 and a sum of 7x, right? Remember that? So it's just 1 and 1, remember that? Now I got to figure out 2 numbers that multiply to 18 but add to 7. If you think about 9 and 2, and then figure out which one needs to be negative, 9 times 2 makes 18. But which one do I want negative if I want the sum to be positive? The smaller one, right? I want this to be negative. Because 9 times negative 2, sorry, 1 times 9 is 9, 1 times negative 2 is negative 2. 9 and negative 2 is 7. Found that on the first try. Yeah, remember that? Karate chop. Once you find the one that works, you plug the x's back in, right? And do you remember what came together? The inner and the outer. If you don't remember this, if you're like, I don't know what the heck you're talking about, Mr. Gillespie. Okay, that's fair. Then you're going to have to go back here. Go to the algebra lessons. I've organized this a lot better this year. Go to the quadratics and start learning how to factor those 3. What we're doing here is we're basically doing 66. If you don't know anything about it, watch 64 through 66. But if you just want a refresher, do 66. Okay? So, I found the one that worked. It's what? X plus 9. X plus 9 and x minus 2. Now this is going to have 2 answers. Yeah? Why did I turn it into 2 things being multiplied? One of them has to be 0. If I have 2 numbers multiplying to 0, that means one of these has to be 0. So either x plus 9 equals 0 or x minus 2 equals 0. Now, you're going to get 2 answered, but that doesn't mean there's 2 answers to the problem. One of them doesn't make sense in the real world. Well, you get x is what? -9, and you get x is 2. -9 doesn't make sense. Why? Because that would mean this is -9. So its distance is -9? No. It's called an extraneous root, right? It's a root that makes sense mathematically, but not practically, yeah? So what is x? X is 2. Say it again? No. Yeah. Well, they could get worse if this coefficient's not 1, right? Yeah. All right. Next one, 5. Looks hard, but it's actually quite easy. What's that chords going through? They're all radii. So that means this is 5, and that means this is x plus 2 also. Now you could do a quadratic and say this times this equals this times this, but if you think about it, what are they all? They're all radii. So that just means what? X plus 2 equals 5. Let me say that again. If you try to do it the long way, 5 times 5 equals x plus 2 times x plus 2, you end up with x plus 2 squared equals 5 squared, right? Square root, you end up with just that. They're all just radii, so they're just equal. So what is x? You don't need all this, is what I'm saying, yeah? Okay? All right. Okay, so look at this segment. It's going to bring up a theorem that you already know. Look at this segment. What's it doing?
Bisecting.
Is it? Well, do I know it's bisecting it?
Yeah.
It's perpendicular. Good. So that's perpendicular, which means it's the shortest distance. And when you construct the diameter through a chord at a right angle, it bisects the angle. Yeah? It bisects the chord, yeah?
Do you have a calculator?
All right. So we know it bisects the chord, so those are both x. So that's going to be what? X times x equals 2 times 7. So we get x squared. Not 2 times 7. Good. All right, so be careful. We know this part, this whole chord is 14 because it's a diameter. And that piece is 2. So 14 minus 2 is what? So this is 12, right? So this is 2 times, I'm actually going to leave it as 2 times 12. It's better, yeah? Square root, we get x is equal to the square root of 2 times 2 times 2 times 3, right? We're simplifying the radical. So that becomes 2 root 6. X is 2 root 6. That hard? And then if they ask you would round it to the nearest tenth on the test, yeah? All right. Next one, let's do it, right? So 2x times 3x is equal to 6 times 5. We get 6x squared is equal to 6 times 5. Divide both sides by 6. We get x squared is equal to 5, right? So x is root 5. All right, I'm not going to do 8. 8 basically the same problem again, yeah? With just different numbers. Okay. Now there's a second special segment. We already talked about it a minute ago, right? Remember what we said here? We said on this one, when you have a secant or a secant with a tangent, the outside times the whole thing is equal to the outside times the whole thing. The same thing here. The outside times the whole thing is itself. The outside times the whole thing. Yeah? That's how I memorized it. So then you just go through the math of that. All right. Okay, so if I'm going on the left-hand side, the AB chord, what is this? The outside is what? Remember we said the outside times the whole thing. So that's what? 18 squared equals the outside times x plus 15, right? Got it? Distribute the 15. Actually, no, yeah, distribute the 15. So 15x plus 225. What's 18 squared? 324. Subtract 225. Subtract 225. What do we get? Is that 99?
Yes.
99? 99 equals what? 15x? Boy, this is going to be ugly, huh? All right, so we get x is what? 99 over 15, which is what? 33 over 5? No, that's not too bad. And then round to the nearest tenth that they asked you to, yeah? Yeah, I'm not going to do it, but yes. I got it? All right. All right, so these are going to get uglier as you go. So let's do this one. What would number 1 be? This would be what? 3.3 times? So squared, right? Equals 2.2 times x plus 2.2, right? Okay. Man, there'd be so much better way to do this one. I'll distribute it. There's probably a better way to do this, but 2.2 x plus what? 4.84. That's 2.2 squared. And 3.3 is going to be 10.89. It's getting ugly, yeah? This one I don't mind if you use a calculator on, but just show me your work, right? 4.84. What are we at? 6.05 equals 2.2x, right? All right. From there, just grab a calculator, right? So what is that? 6.05 divided by what? 2.2. 2.75. Not bad at all, actually. Yeah. So x is 2.75. All right. Let's do number 2. So that'll be 16 times, what's the whole thing? Now look, the very common mistake is to do 16 times 26. Do you see the mistake with 16 times 26? It's 16 times the whole thing. So 16 times what? 16 plus 26 equals, running out of room here, 18 times x plus 18, right? All right, I'm going to do this down here. So what do I get? 16 plus 26 is what? 42, I think? And I'm actually going to leave it as 16 times 42. Becomes, can I divide this by, is that got a 9 in it somewhere? No, it doesn't. 18x plus, I'm going to have to do it. 18 times 18, so 324, yeah. So I'm going to have to multiply that now. It's not going to really help me. So what is that, 16 times 42? Is that what it was? I don't mind if you use a calculator on this. That's not what this is about. 672. 672 equals 18x plus 324 minus 324. We're saying 348? Does that sound right? Equals 18x. All right. 348 over 18. 348 over 18. Sounds like it might be a whole. Is it a whole number? No, 58 thirds, right? So x is 58 thirds. If they wanted you to round that to the nearest tenth, right? If you have an Inspire, you can grab that and just do Control Enter. It'll give you the decimal, 19.3. Yeah? So about 19.3. And I'm not going to solve number 3, but I will set it up. How long is LM? LM 8, right? Because those pieces are equal, right? So it's going to be 8 times 8, right? No, 8 times 16 is equal to 6 times 6 plus 2x, or 2x plus 6. And then just solve it. I'm not going to solve that one. Yeah? All right. I don't. I'll set the rest of these up, but we're not going to solve them. 4 is going to be 13 squared equals 9 times what? 9 plus 5x. And then you would just solve that. Yeah? Easy? The next, I'll do the next one because there's a couple variables in there. So we get what? 6 times, not 4x, be careful. 4x plus 6 is equal to 6 times x plus 3. If we stop and think this through for a minute. Oh, not 6. Oh, okay. My bad. Is equal to what? X. Yeah, hold on. I'm lagging here because the computer is starting to have problems. X plus 9, right? Okay, cancel the 9s, and it tells you something real simple about this problem. Yeah? Those must be equal, yeah? So we get what? 4x plus 6 equals x plus 9. Bring the x over, that's 3x. Bring the 6 over, that is 3, right? So x is 1. Okay? And the last one will be quadratic, okay? So, all right, let's do this one. So this will be 8 times 10 is equal to x times x plus 11, yeah? All right, so we get 80 equals x squared plus 11x. Bring the 80 over. We get x squared plus 11x minus 80 equals 0. Now we're down to one of those quadratics again, right? I'm going to run out of room here. I don't know if you have room, but I don't have room. I'm going to do this on a separate sheet. X squared plus 11x minus 80, right? X squared plus 11x minus 80 equals 0. All right, so I'm going to make my table. Remember this, 1x squared, product of negative 80, sum of 11, right? Well, obviously 1 and 1.
16 negative 5.
Did you guys get it? All right, so 16 and 5 multiply to 80. Which one do I want to be negative? The 5, right? All right, so once I find the one that works, put them back. Remember, you can go back and watch this video if you want to remind yourself. You get these two. Now, which one's going to give you a negative answer? The middle or the end? The middle, because x plus 16, when you make it equal to 0, is going to be negative 16. Yeah? Not going to work here. So I'm only going to focus on the x minus 5 one, right? X minus 5 equals 0. So x is 5. If you ever had this on the SATs, ACTs, whatever, you could probably get away at that point guessing and checking. Yeah? Ooh, I think I just got a real crash. I better not have crashed right at the end. That would suck so bad. Didn't that happen the other day? All right. Wait, what was I saying? I got lost track. Oh, if you're taking a test, sometimes you can just get away with, if you're assuming it's a whole number, right? Just try a couple of whole numbers till you get it. That's not math, just so you know, okay? That's brute force, beat it with a stick. Worst case scenario. Learn the algebra because you're going to need it next year in Algebra 2 anyways, so, yeah? All right, so what do we know? We said x was what? X was 5, yeah? Yeah? All right. That's all there is to it. Those two theorems, if you know those two chord theorems, that's it, right? Good luck with this.